All right, in this video, I just wanted to take a look at a carefully chosen end behavior limit problem. And in particular, I wanted to draw your attention to some of the things you want to think about with regards to square roots, because they can be somewhat confusing. We want the limits at infinity of this function here, which involves the square root at the bottom. So before we even do that, I just want to note that in doing a problem like this, we can always kind of create what's called an end behavior model. Okay, so I'm going to write, as x goes to positive and negative infinity, the function is going to behave like, okay, and I use the term behaves like basically with regard to whether it goes off to infinity or negative infinity or some other asymptote. It behaves like what's called the end behavior model. So we're just going to take a look at the leading power, or the term with the leading power in the numerator, which is 25x. And just scanning the bottom, you can see 64x squared under the square root is the highest power there. So in the long run, f of x is going to behave like that function there, this expression here. Now, I'm not saying they're equal, they're not, but they're going to behave the same way. So if we simplify this a little bit, we'll see, you can write this. Now, be careful, I'm going to do something just sort of going to strike you as odd because I need to discuss the square root of x squared. The square root of 64 is clearly 8. The square root of x squared I want to leave like this for the moment, okay? And I want to discuss how we can think about the square root of x squared, because it's not always x. So let's take a look at when x is a positive number. So when x is a positive number, the square root of x squared is equal to x. Okay, and let's just take a look at why that is with a numerical. So let's just say we wanted x to be negative 10. Well, then the square root of x squared is equal to the square root of, I wanted x to be positive 10. I was getting ahead of myself. Then that's just going to be the square root of 10 squared, which is the square root of 100, which is 10, which is clearly x, right? Okay, so the square root of x squared is equal to x. That's probably what you would think of anyway in doing a problem like this. But when x is a negative number, something different happens that you probably haven't thought about, at least if you're on autopilot. When x is a negative number, the square root of x squared is equal to negative x. So let's look at why that's true. So let's just let x equal negative 10. Well, if that's the case, the square root of x squared is equal to the square root of negative 10 squared. A negative times a negative is a positive, so that's the square root of 100, which is 10. And again, that's because the square root of a number is always going to be what's called the principal square root, which is the positive number. So that's 10. But notice 10 is the opposite of negative 10, so that's negative x. Okay. So what does this have to do with what we were looking at above? Well, what it means is when I evaluate this limit up here, I've got to take note of whether x is going off to positive or negative infinity. So, for example, as x goes to infinity, this limit you could get away with in evaluating correctly even if you were on autopilot. Again, we're using the end behavior model down here. So it's the same as this limit here. Okay, but remember, we got to pay attention to the fact that the square root of x squared could mean something different. So in this case, the square root of x squared is just x. And again, that's because x is going to positive infinity, so we're talking about positive x values. That cancels, and we clearly see that the 25 over 8 is the remaining ratio. Okay, so that limit is 25 over 8. On the other hand, let's say we were evaluating this limit here as x goes to negative infinity. So this is the limit as x goes to negative infinity of 25x over 8 times the square root of x squared. Again, we're just using our end behavior model. But because we're talking about x values that are negative, right, as x goes to negative infinity, that means x is less than 0. We're going to replace the square root of x squared with negative x. And in doing that, we get this. The 25 divided by 8 the 25 divided by 8 stays x over x is 1, and we see that we get, as a final answer, negative 25 over 8, or 25 over negative 8, I guess is what I wrote. Okay, so those are the two answers. And if we just take a quick look at the graph, you'll see that it agrees with our analysis here. Okay, it's a interesting graph that has two horizontal asymptotes, something you probably don't see a lot, at least if you're just taking the run-of-the-mill pre-calculus or calculus class. But look, I've got a graph up here to show you, right? We've got our function and we've got our two horizontal asymptotes, which are clearly different. So in any case, that's just a discussion about the importance of reflecting on the square root of x squared and paying attention to whether or not x is going to be negative or positive.